Hello, welcome to this webinar on best practices for Amazon S3 security with S3 access management tools and S3 block public access. My name is Felix Davis. I am a principal product manager in Amazon S3. So in general, this session is going to be focused on foundational introductory information around how to enable security for Amazon S3. In the agenda, we're going to cover S3 access control overview. There are multiple mechanisms for enabling access control to S3 resources. I'm going to be covering Amazon S3 block public access, which was a new feature we introduced at reInvent last year that enables you to prevent public access on your S3 buckets. Then I'm going to talk about S3 encryption, so different methods for encrypting your data in S3. And then I'm also going to cover a new feature we introduced last year, Amazon S3 Object Lock, for preventing objects from making them immutable. And then lastly, covering some monitoring tools for S3 security. Before I get started into the specific details, I just want to cover generally that our best practice, the most foundational best practice for S3 security is the principle of least privilege. Essentially, what we mean by that is when you look at S3 security, you should really think about who are the specific actors, users that you want accessing your S3 buckets and objects. And then start from a place of default of no privileges, no permissions, and then incrementally add permissions over time to specific project teams or users that need access to those S3 resources. It's a much easier way to audit access, who's accessing S3, as opposed to starting with a very broad open base of users who can access your S3 buckets and then specifically denying permissions after that. So in terms of access controls for S3, there are several different mechanisms. The two foundational ones are AWS Identity and Access Management, or IAM. And then you have Amazon S3 bucket policies. So IAM is a cross AWS service that allows you to identify what permissions and roles AWS users have in accessing what types of APIs and Amazon resources. So this is really the foundational tool. It's very effective in terms of, it's very feature rich in terms of being able to integrate with your corporate directory services. It has multi-factor authentication capabilities. And again, it's a lot of granular control in terms of grouping accounts into groups and then applying policies for those specific groups. So we use them heavily within S3. The second one is S3 bucket policies. So essentially, this is a security policy you apply to an S3 bucket. Now, this more defines who are the people that have access to those S3 buckets and which specific APIs they have. Both IAM policies and S3 bucket policies are very similar in terms of their syntax and structure. They're both JSON policies. They both have the principles, actions, and you can apply condition keys for those policies to get give very granular access to S3. And one example of those global condition keys that is very flexible are Amazon S3 object tags. So essentially, object tags are just one of many different condition keys you can apply in your policies. But what that allows you to do is specify, say, for example, in certain buckets or across different buckets, you want to tag certain objects to be, say, for finance or for HR or for specific users or sub-user groups. So essentially what you can do is create your own object tag key value pair and then apply that as a global condition key in your bucket policies and your IAM policies. So again, it allows you very fine-grained access control for S3. And then also, lastly here, for access control, we have access control lists, which can be applied at the bucket or the object level. Now, access control lists are a little bit different. They do not explicitly deny permissions. They allow permissions to access to S3 objects. So you do need to be a little bit careful in terms of how you use access control lists. In general, we recommend IAM policies and bucket policies as far as meeting your defining what permissions you need to define for S3 access. But access control lists are used. So for example, we have some access control lists that allow you to identify to enable buckets in those scenarios, say public websites, where you do want to enable public access to S3. But in general, Now, what are the differences between IAM policies and bucket policies? So the best way to really look at it is the IAM user policy set answers the question, what can this user do in AWS? So essentially allows you to put kind of the conditions, statements, and policies attached to IAM user groups and users that controls what access to AWS services they have. When you create an IAM user, by default, they have no permissions, so you need to explicitly add new permissions to an IAM user. And like I said before, it controls all AWS services. Whereas the fundamental question that an S3 bucket policy answers is who can access this S3 resource? So here you use the principles. You can use this actually both ways, IAM policies and bucket policies. You can use them both for cross-account access. So in a bucket policy, you can enable cross-account to a specific, say, AWS account ID. But you can also in IAM create an IAM role and then have other people assume that role to get access, cross-account access to your S3 bucket. Now, an important point is that Amazon S3 buckets are private by default. So just the bucket owner and the root administrator have access to S3 buckets. You have to explicitly add permissions for others to do either read or write into your S3 buckets. But both of these, like I said before, are JSON-based policies. Now, we have other tools that help you with what we call boundary enforcement. So, for example, a common mechanism what users do today is access S3 from their VPC or virtual private cloud. So you have applications or users running in your virtual private cloud, and you're able to access S3. We have what's called an S3 VPC endpoint policy. So an endpoint allows you to access S3 over the AWS private network instead of the internet. And also it allows you to attach an endpoint policy on there that can restrict what S3 resources you can access from your VPC. And I'll talk about that in the next slide. A second one is AWS organizations. So organizations is a very nice way to help you structure all of your different accounts across multiple different projects, teams, and groups and sub-organizations within your company. So within organizations, they have what's called service control policies. And what a service control policy does is it essentially establishes guardrails for that project team. So you create an AWS organization and then have accounts associated with that organization. And then you can very granularly specify which API calls for which AWS services all those accounts in that org have access to. So that's a very nice way to set, that's the highest kind of level of setting guardrails for your AWS accounts. And then the third one I'm going to get into later is what's called block public access. So there's several different ways you can make S3 buckets public. And in order to prevent buckets from becoming public, we have a very simple mechanism that allows you to set at the account level or at the bucket level, I want to block public access to these S3 buckets. And I'll go into that in more detail. So VPC, Virtual Private Cloud Endpoints. So essentially before we had VPC endpoints, we introduced these roughly around the 2015 timeframe, and these are very widely used today. It's probably the most common way to access S3 from your VPC. But before that, customers would have to create an internet gateway. So you'd set up in your VPC, you can see on the left-hand side of the slide, in order to access S3 from your VPC, you would have to create an internet gateway and route those calls over the internet into S3. So that there is a cost associated with internet gateways, and people wanted to make sure that they have a private connection to S3. So we introduced the VPC endpoint. So you establish the VPC endpoint in the VPC, and then like I said before, it accesses S3 over the AWS private network, and then it creates an endpoint policy. So there's really what you do with the endpoint policy is saying, for this VPC, I only want to access my company-owned S3 buckets. So in the VPC endpoint policy, you list the bucket names and that you want to restrict access to. And then correspondingly, in the S3 bucket policy, you say that these S3 buckets can only be accessed from this VPC endpoint ID. So you can use that as a condition key in the bucket policy. So that enforces security on both sides, both coming from the VPC and on the S3 side, to make sure that there's no risk on other actors getting access to the data. You're restricted from, get access only from your VPC into those S3 buckets. So that's definitely a very strong best practice that we see many customers using today. Okay. And I just want to say there are other very common global condition keys that are, so principal org IDs is another very common condition key. So restricting access to principals that are within your organization. That's another very common condition key we see in bucket policies. Okay, and then one more access control mechanism that I want to talk about is pre-signed URLs. So pre-signed URLs, essentially how these would be used are if you want to enable temporary access to S3 resources to a large group of users that only over a very temporary period of time. So essentially how this works is that you have a user who creates this pre-signed URL, and in this URL it assumes the permissions of that IAM user and role who creates that URL. And when you create a URL, pre-signed URL, you can have it very granular in terms of you provide your security credentials, the specific bucket name, object key, whether it's just a get or a put, and then you time bound it. You set an expiration date and time, and so it's valid for that until that expiration time. So you can send out this pre-signed URL to give access to thousands or millions of people to access, say, be able to get objects from the S3 bucket. So it's a very useful, flexible tool, but you need to be careful too, because anyone with that URL can perform those actions. So the URL has the credentials of that IAM user who created it. So you do need to be careful as far as how you use this and to kind of guard bound it in terms of times and actions you can do with that. But again, instead of having to set up thousands or of temporary IAM user accounts, you can use this pre-signed URL. So you just need to be careful how you use it. Now I covered a lot of different types of access mechanisms. So I mean, how does this essentially work? So when we get a request, an API call on S3, we essentially look at the unification of all these different types of policies: the IAM policies, the bucket policies, the VPC endpoint policies, the object ACLs, and if any of them have an explicit deny, we deny that API action. But if there's not an explicit deny, there must be an allow. It must allow permission to that specific user to doing that S3 API call. And if there is, then we will allow it, that API call to go through. Otherwise, by default, we deny that action. So it's really the unification of all of these policies. If you have a deny on any of these levels, the bucket policy, IAM policy, we will deny that API action. Okay. All right. So a common question we get is, all right, what does public access mean for S3? So essentially, how we define public access, it's really an overly permissive access on your buckets. So essentially, there's two ways to do that. You can create an access control list or ACL, And so essentially there are some predefined ACLs in terms of enabling it to all users or anyone on the internet, or you could create an ACL to any authenticated AWS user, so essentially anyone with an AWS account. So there are some valid reasons why you would use these types of ACLs. There are many customers who are using S3 for public websites or other publicly downloadable content. So those ACLs have a valid use. However, you need to be careful on when you use them. The second way we consider a bucket to be public is by the bucket policy. And a bucket policy that's overly permissive. So I have some examples here written on the slide. So for example, a principal star has access to resource star, a specific action on pretty much anyone can have any action on any S3 resource. So our documentation has a little more examples on what a public resource looks like. We use automated reasoning engine to be able to scan through our bucket policies and identify ones that we feel are overly permissive. And I'll talk about later how you can identify those. So I want to make clear, there's one thing that often trips up customers is that cross-account access. Now, cross-account access is not in itself considered public access. So for example, if you have a cross-account access bucket policy to a specific AWS account ID, that is not considered public. Now, but if you're enabling cross-account access using an overly permissive bucket policy or ACL, then that is, we would consider that public access. But specifically, say somebody assuming an IAM role, that is not considered public access. So what we did was we created launched this new feature called block public access. So there are essentially 4 security settings that I'll describe later. The next slide. They can be set at the account level and at the bucket level. And essentially, so at the account level is really kind of what we recommend. So making sure that when you set at the account level, any new buckets that are created are either already existing under that account or in the future created, they're all going to block public access to apply to all of them. So we really do recommend you set it at the account level, and ideally you would have a separate account for any buckets that do have viable public use cases. Now, in terms of controlling who can set these block public access configurations, you can use AWS organizations, the service control policies, to really restrict who can have access to changing or modifying these block public access settings. So what are these settings? So essentially there are 4 settings, 2 regarding ACLs and then 2 regarding public bucket policies. So in general, we recommend you just enable all 4 of them. I'll show you in the next slide a screenshot of our console. But really, we see that the vast majority of customers really should just enable all 4 of these. Essentially, what the first one is essentially blocks the uploading of any new public objects with a public ACL. So the first one does not change any existing objects in your buckets, but it prevents any new objects from being uploaded that have public ACLs. The second one removes the public access granted through the public ACLs for your existing objects. So the 2 of them combined prevent any ACLs from providing public permissions to your buckets. Now, an important point to understand is that block public access doesn't remove the ACL in itself, or it doesn't change the bucket policy. It just prevents it from providing public access or public permissions. So what that means is if you turn block public access off, then those ACLs will still be in place and those bucket policies will still be in place. So just go ahead. The block public access is yet another level of ensuring, because again, S3 buckets are private by default. Block public access ensures that those buckets stay private and that they cannot be misconfigured. So continuing on, the number 3 is to enable to block any new public policies from being applied to your S3 buckets. And then the 4th one, essentially, it blocks any existing bucket policies from enabling cross-account or any access via a public bucket policy that, again, I showed earlier in the previous slide. So overall, just to reiterate, pretty much most customers should enable all 4 settings. We do recommend that you validate that this will not interfere with the performance of your applications. So this is the view of the console, and so this is the S3 console, I should say. And so on the left-hand side, what I've shown is I've clicked on block public access at the account level. And this kind of gives a description of how block public access is granted. And you can have just a one-click block all public access. This will enable all 4 of those settings at the account level. Now you can also, the screen for at the bucket level is very similar. You can, once you select on a specific bucket, you can go in and configure these 4 settings. So it's a very simple, just go in for your account, click block all public access. Now we do have APIs. You can configure block public access in the SDK, CLI, API, console. And then in the APIs, you can get your public access status. So you can pull back which buckets are public. So that's really kind of the first step. What buckets are public today? So you can get that through an API call, and then I'll also show you, I'll talk about later some other integration we've done with, say, AWS Config and Trusted Advisor. Now on the S3 console, when you do look at your list of buckets, we do label which ones are public and which ones are not. So again, we use that what's called Zelkova automated reasoning to do the analysis of the bucket policies. So you can identify in the console, if you just click on your buckets, which ones are public. Okay. Now let's talk about encryption. So really, again, so we've got block public access configured. Now we want to do encryption. And so there's kind of 2 levels of encryption. There's encryption in transit. So there's TLS, HTTPS. So if you use the SDK, the CLI, we enable encryption in transit. If you don't, again, we just highly recommend you enable TLS. Now, in encryption at rest, we have multiple options. And it really kind of comes down to what level of control do you want? Control versus simplicity in terms of management. So for encryption at rest, there are 2 types. There's server-side encryption and then client-side encryption. So the most common that we have customers use today is server-side encryption. The most common 2 are server-side encryption, or SSE S3, and then SSE KMS, or Key Management Service. So SSE S3 is where S3 ourselves manage the keys. So there's a master key and then a data key. The data key is used for individual objects to do the individual object encryption, and then the master key encrypts the data key. And in terms of all the key rotation and key management in SSE S3, S3 manages it all ourselves. So it's very simple to turn on. We have default encryption I'll talk about next. But it's a very easy way to just ensure and enforce automated encryption for your S3 objects. Now, if you want more control over the master key, you can use AWS's Key Management Service. So the nice thing about that is across AWS services, whereas obviously the first one, SSE S3, is just specific to S3. So if you want to have consistent, organizational best practices or policies on key rotation or key management, or you can create access control policies to who has access to those keys, KMS is really the best solution. So again, it gives you a lot more control over how those keys are managed and rotated, and it allows you yet another level of enforcement to restrict who has access to those keys in KMS. And a third option is SSE customer provided keys, so SSEC. So that essentially means that in the HTTP header, you send in the key that you want the data to be, the objects to be encrypted with, and we will do the encryption in S3 using your customer provided keys. So that gives you even more control over how the keys are created and managed by yourself, by customers. So all of those are essentially where the objects are encrypted on in the AWS service S3 service itself. You can also encrypt the objects before they are sent to S3 using client-side encryption. So with client-side encryption, you can do encryption with the AWS encryption SDK. So that gives you complete control. It's encrypted before it even gets to AWS. The one thing to note is that in case you do lose your keys, or then you will be kind of stuck in being able to decrypt the objects that are in S3. So you need to be careful there and make sure you have all the provisions on maintaining access to those keys. And the other thing is that other AWS services, you can't kind of do some data analytics on top of S3. It prevents you from doing that because all the data is encrypted. But that is a very viable option. Okay. All right. So that's so now we made it even easier for you to enforce encryption in your S3 buckets by creating this default encryption. So this is a very simple one-time bucket level setup. Essentially, you turn on default encryption at your bucket, so all to ensure that all future objects are encrypted. So that's an important point. This automatically encrypts all new objects in that bucket, not existing objects in that bucket. So when we see a put into S3, and we will look at the header, encryption header for that put. If there's no encryption header, we will enforce default encryption. There are the two options we support are SSE S3 and SSE KMS. Again, this applies to any new objects added to that bucket. So this really helps simplify and enforce company compliance. Okay. Now, if there is an encryption header on put into the S3, we will honor that encryption header as far as whatever encryption standard or keys are input on that encryption header. Okay. All right. So now let's so that's encryption. So we covered block public access. We covered encryption. Now let's talk about object lock. So object lock essentially makes your objects in S3 immutable, or another term is a worm, write once, read many. So essentially that there's a number of different scenarios or use cases where this may come into effect. In the financial industry, this is a very common requirement, say SEC requirements for financial documents and stuff. Legal court cases, that's another area where in a legal proceeding, you want to make sure that any data is not changed or deleted by accident. And then overall, it's another form of safety in terms of mistaken deletes. This is another another tool you can use to prevent accidental deletions, which does happen from time to time. So object lock, this has been assessed by a firm called Cohasset Associates. They've looked at our procedures as far as how we treat objects, immutable objects in S3. So we do comply with meet the FINRA and SEC regulations. It is flexible. It allows you different levels of retention controls. So for example, one is it's called a legal hold, where essentially that's an indefinite time period. So you're not exactly sure when that legal case is going to end. So just go ahead and put all the objects in your bucket on a legal hold, and so that will prevent any changes from happening with those objects in S3. But then with, and I'll talk about it in the next slide, we have two different modes of object lock, governance mode and compliance mode, and in those you can specify what that time duration is. You can set a default time duration, at the bucket level, and then you can specify individual time durations at the object level. So it's down to the object and the object version level. So an important point to understand is that versioning is required for object lock. Versioning also is really a best practice for preventing accidental deletions. So object lock and the object version level. And so we also have auditing and visibility in terms of object lock, in terms of how changes are made, and in terms of the tracking, reporting, alerting, access to those objects. So the two modes of protection, so we have governance mode and compliance mode. Now, and then the key difference is really the level of control you have to change the settings. So governance mode is intended for what we call kind of data protection. So it establishes immutable worm-protected objects, and so again, it prevents against compromise and rogue actors. But the retention can be changed by an administrator. So you would have a key administrator who has controls over the settings for governance mode. So which objects are they on governance mode or not on governance mode, the time duration, the settings for object lock. You can specify a central administrator to having control over the governance mode settings. But then compliance mode, once you turn on compliance mode, then you are not allowed. There is no centralized IAM role that can change those settings. Once you set an object at compliance mode, then that cannot be deleted. Deletes are disallowed even for the root account. So that's really intended for that SEC 17A-4 regulation. And you can move from, say, governance mode to compliance mode, but not the other way around. Okay. So just to summarize, I kind of covered in this section a couple different ways to prevent accidental deletions, and I want to be comprehensive here. So versioning is a best practice. Object lock combined with that to prevent accidental data deletion. Another best practice to use is multi-factor authentication for deletes. That's also a very useful tool to prevent accidental deletion. And then a fourth one that's often used as well, cross-region replication and with an ownership override. So essentially what that means is you have your buckets in one region, you do cross-region replication to another region, but in the buckets in the second region, the destination region, are under different ownership. So that also helps prevent against rogue deletions, not just accidental. So kind of four different tools you have to prevent deletions of your data. Okay, so now we're going to kind of start wrapping up the session. We're going to talk about security settings. So what we've added some capabilities to give you more monitoring and visibility on your public access. So for example, in the S3 console now, we have a very clear kind of viewpoint on identifying what are your public buckets. We use that Zelkova automated reasoning, and then we present that in the console view. We also have worked with AWS config. So AWS config is a really nice way of establishing kind of your managed set of rules and configuration policies, kind of what your best practices, corporate best practices are. And then you can, and AWS config monitors S3 to make sure and identify which buckets do not meet your corporate compliance. So for example, we've created 2 new AWS config rules. So there's a S3 bucket public read prohibited and S3 bucket public write prohibited. So AWS config will help you identify which of your buckets do not comply with your corporate standards. So it's a very nice, very effective tool there. And then Trusted Advisor is yet another way to identify your public buckets. We have some rules in Trusted Advisor that identifies, and this is a free part of Trusted Advisor, that scans and identifies your public buckets. So that's another way you can get a list. So the console, AWS config, trusted advisor, and then we have an API call to get identify which buckets are public. And then the fourth point is Macie. So we've also done integration with Amazon Macie. In general, Macie helps you identify and protect your PII, or personally identifiable information, in S3. So Macie will be able to scan and identify PII data and help you define where it is in S3 and help you kind of identify kind of what things you can do with that PII data to prevent it from being accessible. And then in terms of monitoring security settings, we've, in the S3 inventory, we've now added encryption status. So you can see what type of encryption status is being used for your S3 objects. So is it SSC S3, SSC KMS? So now that's included in your S3 inventory report. And then in terms of more auditing, in terms of access control, we have both AWS CloudTrail, which is the, as you know, the AWS-wide service for tracking API calls. So if you want to see who's actually calling those APIs, it's a very effective tool for monitoring who's trying to access your S3 buckets and objects. And then server access logs as well. So that's an S3 specific service that shows you access logs for your S3 buckets. So the two of them combined give you a very great comprehensive view in terms of who is trying to access your S3 resources. Okay, so so this is my last slide. So essentially, I want to summarize what we say the Amazon S3 security best practices are. So first, important, very important, enable block public access at the account level. So this will ensure that any existing buckets and future buckets, you prevent, you're blocking public access. So you prevent any ACLs or bucket policies from enabling public access. Number two, enable default encryption at the bucket level. So SSE KMS is the preferred method for doing your default encryption. Again, it gives you a nice AWS-wide tool for managing your keys and enabling restricting access to those keys. Three, turn on object lock. Use it in governance mode with a kind of expected lifetime for your data. So that, combined with versioning, is a very effective way to prevent accidental deletions. So that can be a very painful experience in terms of deleting business critical data. Four, in your bucket policy, require TLS, so encryption in transit. Make sure that is enforced via the bucket policy. And then lastly here, turn on VPCE endpoints. VPCE endpoints are, like I said before, extremely widely used, very effective tool to restrict access to your S3 resources. So enable them in your VPCs. These are gateway-style VPC endpoints. You put it into your routing table in your VPC to access S3 endpoints. And then correspondingly, put in your bucket policies these global condition key, enforcing that this S3 bucket can only be accessed by this specific VPC endpoint. Okay, so there are other, and again, other condition keys like principal org ID that are very widely used. Okay, so hopefully this has provided a very good foundation on S3 security. We have a lot of different tools and resources available for you. There's a lot of flexibility in there, but we want to make sure you put in, again, the least and then add specific permissions over time. This is a good primer. reInvent later this year, we'll have more detailed security deep dives to be able to go into deep, say, JSON policies and recommendations there. Okay, so thank you very much for attending this webinar.